All right, guys, today we're going to be moving on to 4.4G, factoring special products. And believe it or not, this is actually the last section that we'll have on factoring. So we're finally going to finish it today. So I just want to jump right in, work on a couple of examples, and I'll let you get on to your practice. So this is just a continuation of what we've been doing. We're just talking about special products. So let me start here. I'll start with example number one. And so if you had like x plus 3 squared, for example, let's remember that that is not like just taking each part of this squared, but this is literally telling me that I need to repeat this entire binomial twice. And so we would end up with x plus 3 times x plus 3, which again, if we FOIL this out, we're going to end up with x squared plus 3x plus 3x plus 9, which is going to give us x squared plus 6x plus 9. So it creates this perfect square trinomial is what this is actually called. So if you notice here, actually we end up just kind of squaring this term. We end up squaring this term, but you have this term in the middle that is created. And basically, look at this. You have 3 here, and this is 6. So basically, you're just doubling this. So if you take 3 times 2, you're going to get 6. And then you're also just throwing in this x as well. Okay, so this is a kind of a special situation that's created here when you have this particular situation. So this is a perfect square trinomial right here. I also want to show you another example here of a difference of squares. And so if I have a similar situation, but a little bit different, if I have x plus 3 times x minus 3, again, this is a little different here because I have different signs. So difference is a difference symbol, subtraction symbol, right? So I've got different signs here, which creates a totally different situation. I have x times x is x squared, x times negative 3 is negative 3x, and 3 times x is positive 3x. And then I have 3 times negative 3, which equals negative 9. And notice what happens with these middle terms here. These middle terms end up going away because 3x minus 3x is just going to go away. So I end up with x squared minus 9. And so we said when we have this particular situation here, we can just do FLA. We don't have to do full-blown FOIL like we do over here because I'm really just taking my first terms and multiplying them, and I'm taking my last terms and multiplying them, and it gives me this answer here. So this is a difference of two squares. Over here, this is a perfect square trinomial. So what ends up happening when you start to factor is you start to recognize and you start to see these particular situations. Okay, so let's look at some more examples here, and we're going to. Sorry, I need to just move this up. So we're going to move this up here, and now we're going to look at a couple of examples. So let's call this one, we'll call this actually number one, okay? Those were just examples that we did up above. So now I'm given something like this. I'm given x squared plus 12x plus 36. So it is a trinomial, okay? So I don't have the situation that I had over here because this was just a binomial, but I may in fact have this situation here, okay? This is just a matter of kind of noticing what you have and trying to figure that out. So if you look here, I have a perfect square here. I also have another perfect square here. So remember, we're always trying to get them to look like this, right? I mean, we're trying to figure out and factor out some binomials. So let's think about what makes x squared. Well, x times x would give me x squared. So if I have x there, then that will satisfy that condition. And this is a perfect square as well. So it may be a perfect square trinomial. Let's just try it. I mean, there's no other way to really figure this out. So the square root of 36 is in fact 6. And notice I have a positive symbol here and a positive symbol here. So it stands to reason I should probably put a positive symbol here. Now the way we can always check is we can go ahead and FOIL this back out and see if it actually comes back to this same answer. If it don't, then something's wrong, right? So let's take a look at this. If I FOIL this out, x times x gives me x squared. X times 6 gives me 6x. 6 times x gives me 6x. And 6 times 6, in fact, gives me 36. And notice what happens. My middle terms here, I would add those together. Those are like terms. So I end up right back at the same exact answer that I had up here, which tells me that this is correct factoring. This would be the correct answer. Now I can make that even a little bit simpler because look, these are exactly the same binomials. So I could also write this as x plus 6 squared, okay? So this would be the factored form of that particular problem. Now let's look at number 2 here, where we have x squared minus 49. So there's a couple of questions we're going to ask ourselves. Well, number 1, is this a perfect square? Well, sure, there is a variable that I can multiply times itself that would give me x squared. If I take x times x, right, it is going to give me this x squared. The second question is this a perfect square? Well, yeah, because I can take the square root of 49, and the square root of 49 is going to give me an answer of 7, right? 7 times 7 is going to equal 49. So it is a perfect square as well. And notice the symbol that you have in between, okay? You have a difference symbol. So this is a difference of two squares, all right? It is literally just like the words indicate. So it is a difference of two squares. So when I have a difference of two squares, let's go back up and look at what we had just a few minutes ago. The difference of two squares, x squared minus 9, if we were to work backwards, what's it going to be? It's going to be the square root of x squared, which is x, the square root of 9, which is 3, and I'm going to have different symbols. I'm going to have a plus and I'm going to have a minus. So that is actually what I do here. All I have to do is create my two binomial terms. The square root of x squared is x and x. The square root of 49 is 7 and 7. And remember, because I have a different symbol here, the only way to get a different symbol with multiplication is by having different signs, by having a positive and having a negative. So if one of these is positive and one of these is negative, again, if I FOIL this all the way out, I'm going to get this same exact answer right here. We'll do it real quick. So you get x times x is x squared. X times negative 7 is negative 7x. 7 times x is positive 7x. And 7 times negative 7 is negative 49. And again, these terms cancel, so I end up with x squared minus 49, which is what I originally started with. So this would, in fact, be my answer. So again, I'm just trying to get us to a point to where we could recognize and see that these things are really happening, and then be able to very quickly get to this answer or this answer, either one, without having to spend a whole lot of time. All right. So let's take a look at two more examples real quick, and these are a little bit different, but again, the same exact premise involved here. So let's go ahead and say number 3 is x to the 4th plus 18x squared plus 81. So now we're asking ourselves the same questions again. Do we have any perfect squares? Because these are special cases. So do I have any perfect squares? Do I have a number or a variable that could, when multiplied times itself, would come up with x to the 4th? Well, I know that x squared is the same thing as x times x, which is the same. But how could I come up with x to the 4th? What if I took, with x to the 4th, if I took x squared times x squared? Well, when I multiply exponents, I actually add them. So that would work. And this is exactly the same variable terms, right? So this is, in fact, a perfect square. I can take x squared times x squared, and it would give me that. Now, I can also see that this is a perfect square. I have 81. So the square root of 81 is 9. So 9 times 9 will equal 81. So I have perfect squares here. Let's see, I don't have a difference symbol. So I know it's not the difference of two squares, but possibly it is a perfect square trinomial. So watch what happens. I can go ahead and make my two sets of binomials. And here, instead of x, I'm going to have x squared, right? X squared times x squared makes x to the 4th. The square root of 81 is 9. And notice I have nothing but addition symbols here, which means I'm going to put addition symbols here. Let's see if that worked. And again, if it don't, just try something else. just go back to what you already know, okay? So if we take x squared times x squared, end up with x to the fourth. X squared times 9 makes 9x squared. 9 times x squared is 9x squared again. And 9 times 9 is, in fact, 81. And notice what happens here. My middle terms, they are like terms. So x to the fourth plus 18x squared plus 81. I come right back to the same answer that I started with. So I know that this has to be correct. Okay. And once you get confidence with this, you don't have to go through and do all this full process. I'm just showing you that it does actually work and that these are the correct answers in a way that you can go back and check your answers. Okay. But once you get confident with this, you can really start to kind of do this stuff in your head, especially full. You can start to kind of just visualize what's going on and hopefully be able to just finish that out. So let's talk about number 4. I have x to the fourth minus 144. Notice I do have a different symbol this time. I do have just kind of a binomial term. We know that 144 is a perfect square because 12 times 12 would equal 144. And again, you could always go to your calculator and just put this in as a square root and see if it comes up to a whole number. And so we know that that is a perfect square. We've also just discovered that x to the fourth is a perfect square by this problem. So we know that that's x squared times x squared, which means that now I can go ahead. I've got a perfect square here. I've got a perfect square here, and I've got a different symbol in between. So I do, in fact, have a difference of 2 squares. So when I have a difference of 2 squares, I'm just going to take the square root of x to the fourth, which is x squared. I'm going to take the square root of 144, which is 12 and 12. And notice how I'm just kind of leaving the symbols, leaving the operation symbols out, leaving myself a little bit of room. And now I just have to, in order to get a difference, right? In order to get a difference by multiplication, you have to have one positive and one negative in order to make that happen. And again, if we FOIL this out, I'm not going to go through that process, but if we FOIL this out, we're going to end up right back with that same answer of x to the fourth minus 144. So this would be our answer that we're looking for here. So again, hopefully this has been helpful. Factoring special products. That's what we're doing today. And I know that you're going to do well with this. Just let us know if you have any issues, and we'd be glad to help you out today.